All right, so on this page, we will use a regression to make a prediction. So our situation is a high school student is doing a project investigating the relationship between temperature and shuttle launches. A scatter plot of the data is shown below. So here's a scatter plot. We're going to figure out what type of regression we're going to use. We're going to do it, and so we're going to get an equation that models it, and then we're going to use it to estimate. So what I did is I actually already put the data in, like from here to here, just to make it a little faster on this video, and you already know how to insert the data. Now, one thing I would like you to do, okay, there's two ways of doing this, but I think this probably is the easiest, I think. So we're going to go to Document, and we're going to insert data and statistics. Okay, we're going to go to insert data and statistics right here. You could also, before I do that, you go to your home screen and you can click data and statistics here. So I'm going to click it. Now, if you notice, that's our other page, that's our data. This is our data and statistics, like how it shows up. So I'm going to click on my x-axis. I want it to be temperature. See your temperature. My y-axis, I'm going to make launches. And there it is, like right there, right there. Looking good, right? So we can tell that I'm going to use a linear regression. So actually, let me move this a little bit to the right. And let's do it. So I'm going to go to Menu. We're going to Analyze. We're going to perform a regression right here, and where we said it was linear, so I like mx plus b. And there's our equation right there. I wish there was a way of zooming in, making it look bigger, but we'll just keep it like that. So this is y equals 0.059, 0.059, and then there's a 5. So what happens is the 5 makes the 9 to a 10, which turns to this. So everything sort of changes. I'm going to round. I'm not going to put all those. You can if you want. Instead of putting 5, 9, I guess all that rounds to that. And then x plus 3 point, I think that plus can be better, plus 3.248. And then that was a 2, it doesn't change anything, so it's just that. So the equation y equals this can be used to model this relationship and make a prediction, or we'll say make predictions. So what we're going to do is use this equation to make a prediction. So it says, what will be the estimated value of shuttle launches when the temperature is 50 degrees? So the 50 degrees, so remember that this is the temperature, and this is the launches, or these are the launches. I guess I can make that a little better. Whatever, you get the point, because I can't see any of this. Maybe I should do it like that. Temp, and these are the launches, because these are the y values, right? So I'm going to put y equals 0.60 times the temperature, which it gives me is 50, and then plus 3.248. Now I'm going to go to my calculator. Let's see. I like pressing that running calculator, but if you prefer, you can, just use that. If you prefer, you can go home calculate, whatever. So I'm going to type in 0.60 times 50 plus 3.248, and I get approximately 33.248. Remember, this is all kind of rounded. That's kind of why I put approximately, because these was rounded, So that means how many shuttle launches will there be? Well, let's just do as little as possible. 33.248, or approximately. 33.248 launches. Oh my goodness. Okay. What is happening? Okay. Awesome. Let's go to the next one. Okay, so once again, I am going to insert all the data and I'm going to delete this and all that stuff. Oh, let me show you how to delete this stuff if you don't need it. So, see this little blue thing up here, or this, yours is yellow, so control up. You can see what you have, and then if you press delete, it'll go away. And I'm press delete, it'll go away. So then I click it, and then it says press menu. I want to add list and spreadsheet. Okay, so give me a moment. All right, so I entered all the data up at the time. Remember, this is my X right here, and this is, ooh, that was weird. That was my X, and this is my Y. So time, altitude, time, altitude. So I'm going to go to control. I'm going to add a page, and I'm going to add data and statistics. And I'll put time, altitude. Ooh, that looks a little weird, right? Let me make sure I put in the data right. Let's see. But you know what? So that's 1.5 to 2.1. I'm going to change this. I mean, it's not that it's wrong. There's nothing wrong with this. I think it's just going to be harder for you to see something like that I want you to see. So I'm going to go back a page, and I'm going to change this 28.3 to 26.3. And so I'm going to change this 26.23. And then I'm going to go back to my other page. And then, you know what? I'm going to change this 23.23 just to do it. 20, just so you can see it a little better. It's not always going to be nice. It's hardly ever nice. Okay, so see, this looks a little more like quadratic. That's what it's supposed to. That was just my bad, right? So let's get an equation. Menu, analyze, regression. This time it's quadratic. So we know it's quadratic. And ooh, this one's going to be a tough one. Y equals negative 14.66 if I round it, x squared plus 45.26 if I round it, right? Plus 0.641, we'll say. So I can use that equation to model this relationship and make predictions. So what would be the estimated altitude at 4 seconds? So I guess I go back to my calculator. I guess I'm going to put negative 14.66. Instead of that, I'll put, instead of x, I'll put 4, and then 45.26. Ooh, I forgot the x. There was an x there. X, so instead of x, I'm going to put 4 plus 0.641. All right, let's try this out. Negative 14.664, and then I'll put squared plus 45.26 times 4 plus 0.641. So it gives me negative 52.879. Negative, oh man. It's kind of weird. That's like inside the ground. Remember, this is a projectile. Well, this is a projectile, by the way. It's going like that. So it's going to keep going into the ground. So it's a negative 52.879. If you have enough room, I'm just going to put the units here. So altitude, that's feet. Oops. And then you can just... Okay, cool. One more page. Once again, I'm going to put this data in. I'll be back. Alright, so I have this data. I'm going to... Let me zoom in on this first. Let me see if I can get this around. So, the amount of zombies seems to be changing very quickly. The data shown below. So we have this data, right? And so we want to figure out what it looks like. So I'm going to go here. I'm going to add a page. It's going to be the data statistics, days, zombies. And you can tell it's going to be exponential. Oop. Exponential. I don't like how that looks. A little better. So let's run a regression. Menu, analyze, regress, exponential. I can move this. So this equation is y equals 3.385. So that 7 makes the 5 turn to a 6, or round it to a 6, times 1.1953. The 3 makes the 5 remain unchanged, to the power of x. Remember that this is x and this is y, so these are the days. So these are the days. And this is the zombies, number of zombies. And that's the model, that's the equation that can model this relationship and make predictions. Just make sure when you do this one, that when you do it, so it wants to know 26.5 days, right? Just make sure that when you do it, that you put this to the power of. So this is 26.5. It's not multiplication. All right? I assume you can do that. So that's it. Thank you.